My name is Daniel Sa'ar. I'm a third-year PhD student, and I'm going to be talking to you about the electrical sector of Project SunRise. Before I start, I'll give you a brief review of the electrical sector. In 2012, Lille 1 and Professor Isam met with Eiffage Energy, and they started an affiliation regarding the smart grid concept. Through this affiliation, they began in the later 2012 implementing and upgrading the entire high-tension network of the electrical system, of the electrical network, excuse me. And now I'm going to be showing you what's been happening since 2012 until today. Now I'm going to be going over the steps that occurred over the past 3 years. We started off by creating an urban information system based on GIS, with the purpose of facilitating a way to visualize our electrical network. Then I'm going to be talking about the electrical grid itself, and then the data collection, data analysis, and the work we're working on right now and our future work. Now, we started off by splitting the layers of the electrical network to understand the infrastructure itself. Afterwards, we took these sub-layers, which are the high-tension network, the low-tension network, and the AMI infrastructure, and we implemented them into the SunRise geodatabase. This means we georeferenced all the features of the electrical grid, giving us easy access to data at any time during the day. Now, as I mentioned, the high-tension network is composed of 3 sub-layers. We have the substations that contain the smart meters. We have and the electrical equipment, I'll explain later on. The transformer network, as well as the transmission systems. We have a data network, as well as the 20 kilovolt high tension lines. Now, by implementing these into our geodatabase, we have a clean view of what the high tension network looks like. Now I'm going to give you a look inside one of the substations. Now, when the substation receives this high voltage from the main distribution lines, it takes this voltage into the main high-tension distribution panel. Now, this panel has 4 cells. The first cell takes the 20K, passes it along to the next substation. The second cell receives the 20 kilovolts and passes it through the transformer cells to the transformers themselves, where the voltage is stepped down to 380 volts, which is the distributed voltage. After the transformers finish stepping down the voltage, it's passed to the low-tension distribution panel, or the distribution panel, basically. Now, this panel is responsible for distributing the step-down voltage to all the neighboring buildings on the low-tension network. And here, in fact, is where the location of these smart meters are, which I'll get to. Now, what are the smart meters used for? What was the reason behind this upgrade to the network? The smart meters give us the capability of monitoring in real time and remotely consumption levels, current per minute, power, reactive and real, as well as power factor and frequency, among other things. As you can see, these are graphs that display data in minute by minute, any time during the day. Now we move to the low-tension network. The low-tension network has 2 main sublayers. The first one is the distribution system, which is made up of the distribution substations. These are smaller substations, don't contain the same electrical equipment as the main substations. They're responsible for also delivering the step-down voltage to other neighboring buildings. The second sublayer are the distribution lines, which we contain the lines' locations, the lines' length, and their thickness as well, and store them all in a database as well. They comprise the low-tension network. Now, by mixing both the low and the high-tension network, we have the electrical grid of Project SunRise. Now, what was the change done in 2012? What made this electrical grid smarter? For one, we'll talk about the reliability, the safety, and the security improvements that were made. I'm going to run through how this network works, show you an example. Now, to start off, the EDF, the main EDF lines, arrive into the Lille 1 campus. After they arrive into Lille 1 campus, they become the network itself is privately owned by the campus, which gave us this easy way to change it as we please. So after the EDF lines arrive, they move in two separate directions, moving through 19 substations and arriving at one substation which has the principal switch of the entire network. In parallel to this high-tension network is the data network. It's a fiber optic network that takes this data, takes all the data from these substations, from these smart meters, and relays them to the main server located in the main substation of the entire campus. Now, once the data reaches the server, it reaches it as random data, not useful. When it reaches the server, it is compiled and made useful and available for extraction by a user, and is also stored in SunRise's database. Now let's say something happens somewhere along the network. Some fault happens somewhere along the high tension network. Immediately, the system knows something is wrong. It takes about 15 seconds to locate where that problem is. And in under a minute, the system will locate the problem, will isolate the problem by opening the electronic switches inside, and simultaneously will close the principal switch inside, for example, building M6, thereby rerouting power to the neighboring buildings, thereby healing itself in less than a minute, whereas today, if these problems occur, it could take from 6 hours to a whole day to locate, to get someone to come and fix it. It's a hassle. Now, the next step is the data. Now, this was the longest phase so far, where we had to collect all the data concerning the network's consumption and try to find some use for it. The data is available at an hourly level, at a daily consumption level, and as well as a monthly consumption level. These all come from the server itself, stored on SunRise's database from all the previous years until now. Now, from this data, we're able to do studies, some data analytics, where you want to find, examining this data to draw some conclusions, some beneficial conclusions. Here's an example of the EDF contact with Lille 1 University. Now, before the smart meters and this system was implemented, the university had no idea how much it was consuming, what the demand was. They used to use some kind of formula to generate what the university should consume. So we had a subscription for 5,250 kilowatts. And you can see the blue line below is what actually the university consumed, for example, the year 2014. So all this in between is wasted money. It's a loss for the university. And thanks to this system and not too long analysis, we came to this conclusion. Other studies we use is we can also take the data over a given month, over given buildings, and compare them, look for anomalies, look for some unusual consumption levels. Another study we've done also is we compared the kilowatt hour consumption to the size of the building, the meter squared ratio. From this ratio, we get to compare the buildings themselves, why a building that is certain size consumes more than a building that is bigger, for example, which leads us to the future work that we began working on, which are the perspectives of the presentation, where we decided to not only focus on the global vision of the high-tension network, but to also work on a local level, to work on the low-tension network. So right now, through our previous analyses, we can see which buildings are consuming absurdly amounts due to their construction size or due to their usage, whether they're teaching buildings or administrative buildings or residences or restaurants. And we use a form of monitoring where we can actually split the source of consumption. We don't just know how much the building consumes as a whole, but rather from the source of every device itself, and which can lead us to also future studies again in the future. Thank you.
Thank you, Daniel, for this excellent presentation.